I'm Luca Deganutti. I'm from Italy, and I work with Professor Massimo Faccoli. I'm doing the PhD. And I just want to present some results we had with this push and pull technique in Italy. It was really interesting to hear about results, also the IFE SAS, and I'll just show you some of our work. So I just go really fast. You already know that push beetle is the most destructive pest in Europe for coniferous forests, and it attacks mainly Norway spruce, Pichia abies. And of course, we are observing something changing in the recent years, and it's because of climate change. And climate change is affecting, of course, the host tree in a negative way with higher temperatures and modifications in the precipitation regimes, and is also affecting, of course, positively this pest. And here you can see the main symptoms of an attack of this beetle. You have the entrance holes with red dust when male and female adults are digging the holes in the galleries inside the phloem. And of course you can see the galleries, maternal and larval galleries in the phloem. We can observe needle loss, and at the end we see all the canopy that is turning red because of the attack. So that means that the tree is dead. And I was talking about climate change and triggering factors of these outbreaks. Normally, the Ipsipolyphus is a good animal for our environment because it can choose the right tree to attack, which is usually already not so healthy tree, and so it's a positive thing for our forests. But several factors can change this situation and go from endemic populations to epidemic populations. And for example, we can have heat waves that can trigger this phenomena, and drought, of course, and last but not least, wind stress and wind damage. So in Italy, we had quite a big windstorm in October 2018, which is called Via storm, and this storm damaged 16.5 million of cubic meters of timber. For us, for the Alps, it's quite a lot. We never had such a big event, but I know for the Central Europe it's quite a small number actually compared to other storms that happened in the past. And our study focused in the northeast part, which is the Friuli-Venezia Giulia region, and that part in the circle. So we started in winter 2019 and 2020, so 1 year after the storm, and we wanted to see what happened in the wind-thrown areas. So we did these surveys in 44 areas, and we checked 30 trees for each wind throw, and we classified those trees if they were infested with the overwintering generation under the bark, or already degraded, colonized maybe by the previous generation, or dried by sun, and at the end, fresh and uninfested trees. And this was really important because we then wanted to create this risk assessment for wind throws in the area. And as you can see, in average, we had 18% of the wind-thrown trees that had the beetles inside, which is quite a big number, and 51% were degraded and no more suitable for colonization, and the 31% that were still good for Ipsipolyphus. And so we created this risk assessment divided in 3 categories: low, medium, and high infestation risk, and we created these maps basically for the local forest service, so they know what was the situation with these wind-thrown areas. And here you can see that the graphs represent the percentage of these 3 categories: infested or uninfested or degraded. This is important because in the first year of the study, of of course, this is the scheme of push and pull. We had windrows, and within windrows we placed pheromone traps to attract the beetles. And in the newly formed forest edge, we had repellents to push away the beetles. And the repellents were placed just at breast height and not up in the tree, but Christian will show you how it does later on in his presentation. That's really interesting. And so we had 2-year experiments. In the first year we had 24 windrow areas divided in these 3 risk categories. And in 2021 we had just 20 clear-cut areas, so we had a different situation. We had like these clear cuts created by sanitation logging of infested forest. So this is, keep it in mind because it's important also to discuss the results later on. This is just a table. You can see the repellents and the aggregation pheromones we used with the release rates and purity, and as you can see, the repellents we used were verbenone, conoftorin, and GLVs, green leaf volatiles, that Synergy provided us. And this was the scheme. We had, for each windrow or clear-cut area, was just a treatment site or a control site, and we treated all the forest edge length with repellents and traps. So we had repellents on the forest edge trees and traps in the right number with, let's say, the length of the forest edge. So let's start with pheromone trap catches. As you can see, we obtain a similar trend that follows, let's say, the risk assessment, but we didn't notice significant differences. And also in 2021, the second year experiment, we had quite higher catches, average catches per trap, 23,000 compared to 18,000 in 2020, but it was not significant. Here, the most interesting part, these are the results of the first year of the experiment in windrow areas, and as you can see, it worked really, really well, especially at high risk. As you can see, at low and medium infestation risk, we had really low forest edge damage, or number of tree killed in the forest edge, and at high risk, it really worked well with the push and pull techniques, with repellents and pheromone traps. We also tried to use just the traps, but that was not enough to inhibit the attack on the forest edge trees. However, the second year results were worse, and you can see that we didn't find any statistical differences between control sites and push and pull sites in 2021. So we asked why this happened, and okay, just to summarize, the push and pull technique worked well in post-windrow conditions and worked not that well in clear-cut areas, and of course the use of using just the traps was not enough in our case to limit the attack. But we considered different possible factors that affected our results. First of all, in the trials for the first year, we had, of course, the windrows inside this, let's say, clear cut created by the storm, and so the presence of the windrows could have attracted a bit in the fresh logs, still fresh logs part of the population of the bark beetles, and of course could have also created different dynamics with predators and parasitoids. There are many papers that describe these dynamics in windrows and in infestations, and it's really interesting. So, and then maybe in 2021 we had growing populations, higher population densities, so the insect was much more aggressive in our study areas, and as we can see, as we know in literature, the population of Hypstipographus generally peak at the third year after a storm. So that was 2021 for us. And then generally it decreases, but then we have many factors like drought and climate, and so now the situation is slowly decreasing populations in Italy, however. And then, as you can see, we had also better climatic conditions for Hypstipographus in the second year compared to the first year. So the climate could also have affected the results. If you want to read more, we have published these results. This is the publication, and with that I thank you for your attention.